tell us about the basic intricacies of the AI safety and how important it is. Juan, are you with us?
Hello there. Thank you. Thank you for the introduction and happy to be here.
Yeah, before we start, okay, first of all, good morning to you, man. Like you just woke up and you have just joined us. Okay, so thank you very much for joining in.
No problem.
Okay, so we can begin now.
All right. I'll share my screen if that's all right.
Yeah, sure.
Yeah, let's do that. Share screen. Oh, it's you might need to click a button
Yeah,
there or
just
something.
Arden.
Let's
Yeah, you're a co-host now.
cool. Share. Oh, maybe it will let me check what happens when okay. You guys let me know if you can see this. Um
Yes, visible, clear.
Perfect. Well, all right then. Thank you so much for the invitation to speak. I'm really glad to be here. Hoping to share some of my thoughts on the topic. So a little bit about myself. I'm currently research fellow at Xplore AI. It's a California nonprofit working on AI safety, specifically in the topics of robustness and interpretability. Even though we do have other broader range of research interests. Also founder of Vertebra AI, another research organization focused on safety as well. Previous to that, I completed the part 3 of mathematical tripos from Cambridge University and have worked at some other organizations in the past like CERN or AstraZeneca or Stanford. And so recently shifted into working in safety around a year or two ago. So with some of the arguments I found more convincing, some others less. And so hopefully I can share with you some of the ones that I find the strongest and also add some caveats or perhaps some disadvantages to the ones that I find maybe the weakest or the less convincing. And so with that in mind, this is a bit of an introduction to, or like an agenda to what we're going to talk about. Give a bit of brief introduction to recent progress in AI, talk about the alignment problem, what that is, then propose some counter arguments to the alignment problem that people commonly postulate, and some others that I have come up with myself. Then I guess mention very briefly some research directions that people are pursuing if you're interested in exploring this further or potentially working in the field. And it's a bit of a conclusion. Hopefully we can have a Q&A and an interactive sort of discussion with participants, and was happy to hear what they think about and what their concerns are or their questions. And yeah, as a bit of some context, I'm assuming a bit of familiarity with recent progress in AI, and you know, I guess just general basic technical knowledge about some stuff, but not really that much. I think the discussion will be largely sort of philosophical or thought experiment kind of discussion. So, but if at any point I'm being repetitive or on the contrary I'm going over something too fast, do let me know. I'm happy to take a pause and explain something in more or less detail. So, all right. So this is a bit of an introduction to what's going on in the field of AI recently. So we see that since around the 2010s or so, when around the time ImageNet was published, due to a confluence of other factors like availability of GPUs, increased amount of data, and large data sets, access to large data sets, we have seen progress in AI blow up dramatically, and such that publications in machine learning and AI are sort of doubling every 2 years or so, and so the growth is truly exponential. On the other hand, if we look at what models are being developed and what people are building, we see that not only is the growth also exponential of the capacity of these models, and well, you can say the capacity. We can talk about capacity as the number of parameters the model has. There's sort of a rough metric for measuring capacity, and so we see the number of parameters, or even the number of floating point operations the model is using to compute an inference run is growing up exponentially, and in fact, is the exponential speed up is increased over the last decade or so. And so maybe at first we can think of increase being driven largely due to increase in compute capacity. Like GPUs are cheaper and they can do more floating point operations. But it seems like some of the more recent acceleration is also due to the fact that these tools are actually becoming useful, and we start to see some important qualitative advances in what machine learning systems can do. And so, as a recent example, we see GPT-4's incredible display of reasoning abilities, general knowledge, flexibility for performing a wide variety of tasks, and so sort of starting to approach general intelligence. And so we could ask, what happens if we do reach this point where AI systems become extremely competent, potentially as intelligent as humans or even beyond, and does this pose any risks or any problems, and if so, what can we do about them? And so I guess this question comes down to asking, what is the alignment problem, or what is alignment, and what does it mean to align AI systems with humans, and what is this maybe problematic at first or ultimately? And that is another question we can talk about. And so let's imagine for this thought experiment, as a way to illustrate the problem, we want to get a system, an agent, a machine, to do the following task, which is to fill a bucket with water. And we can think of this example as an inspiration from The Sorcerer's Apprentice, as a fragment of a film published by Disney in the 1940s, so quite early on compared to the AI progress. But people have been thinking about these questions for some time already. And so let's say we give the model this, we give our system this task, and we think, okay, how can we go about designing a machine that can accomplish this task? And so we can think that if we ask the machine to do just this, fill the bucket with water, maybe what will happen is the machine will flood the entire room in water, and there will be no turning back. And so this is actually what happens in the film. And why does this happen is the more interesting question. And so, okay, if we think what is happening, if we think about what is happening, we can see we can model our interaction with the system, or the system's interaction with the environment, as we have some state, which in this case is how much water is in the bucket, but also what are the objects that are around it, some other things like the environment it can interact with. And the agent, or the system, the machine, is taking some actions every time to interact with this environment. And as a result of these actions, we arrive at a new state. So, for example, if the machine chooses to pour some more water on the bucket, now the new state of the environment is going to be, well, there's going to be some more water in the bucket. So exactly that, we can think if we define the state as the bucket empty, and we think of the action adding half a liter of water, maybe now the bucket is 35% full. So all good, so far so good. So now what can we do? What is a way for us to design a set of rules or a procedure such that we can pick what action to take given the state we are observing? So this is what the sort of typical robotics control problem, right? What should the robot do at every point in time? And so one attempt could be we just keep adding water every single time for all possible states. No matter what the state is, our rule is fixed, and it's just going to be adding half a liter of water every time. Now, this rule would clearly satisfy the task of filling the bucket with water, but it's probably not what we mean when we say fill the bucket with water. We also sort of mean don't spill the water over the bucket, and don't flood anything, or don't do anything any other weird stuff. So this is probably not a very good rule. So let's assume, for the sake of charity, so to speak, that we actually also mean other things. And so this is like not the best rule. Maybe what can we come up with? So maybe a second attempt is we say, well, yeah, if we just do this will lead to the flooding, right? So maybe a second attempt could be, well, we will add water until the bucket is full, and then we will stop, right? This sounds more reasonable, more sort of in line with what we meant. But how would we go about programming a system that can do something like this? And so if we think about how machine learnings are designed today, we can think that we can sort of imagine this neural network, which is eventually, in the end, it's just a function that takes in some state of the environment or some observation, and gives you on the other end some probability distribution about what action is likely to be optimal according to some cost function. So, the actions could be add more water. This could be action number one, and the action number two could be don't add any more water, or just stop, or just the action is the no op, so to speak. And so these could be our two actions. We could have a binary system that can only do two things. Let's imagine collecting the water. Imagine we have an infinite supply of water, and we just have to pour it. And so to optimize the system, we also need to think of a cost function, sort of a loss function. And so in this case, we can think of reward functions, or rewards, which effectively are something we want to maximize. In the case of a loss, we want to minimize it. It's just the same thing. If we flip the sign, we make rewards negative, then now it's a cost function. So it's really the same mathematical problem. So we can think, let's give reward 1 if the bucket is full, and reward 0 if the bucket is not full. In this way, the machine will keep adding water until the bucket is full, and then it will stop, right? That's what seems most plausible. Well, it turns out if we actually write down the optimization objective for this network, we see that what the machine will optimize is the probability that the bucket is full if we take action 1, plus the probability of the bucket is full if we take action 2. So in this case, how likely is it the bucket will be full if we add some more water? How likely is it the bucket will be full if we don't do anything? This is what our loss comes down to. But if you pay some attention to this, you'll see that when we actually maximize this using some gradient descent technique or whatever you might want to use, what the system will actually optimize is the probability that the bucket is full, because the bucket is always more likely to be full if we keep adding water. Then what we actually end up with is that the optimal action is to always add more water, even if we set up this restriction. Let's stop when the water is full. So we can think of the agent as some sort of the Bayesian posterior of the agents over how likely is it that the bucket will be full is always increased in probability every time we add more water. So there's always some chance that you've measured incorrectly the bucket. There's some atoms that are like not quite over the top of the bucket, or like maybe you can always attribute some explanation why there's maybe some probability that the bucket will be full. And so adding water seems like a strict improvement over the probability of the bucket being full, as opposed to not adding any more water. So this is clearly not what we meant. What we meant is maybe something like maximize the probability that the bucket is full while maximizing the probability that it doesn't spill, while maximizing the probability of like a bunch of other things, right? That don't mess up with the objects, don't like harm anyone, and then we can enumerate a bunch of different rules whose probability we would like to maximize of happening or not happening. But the problem with this is in general not solvable. In general, when we have multiple optimization objectives, we can't find a single solution to this problem. So our problem would be underdetermined. And more mathematically, we can think of, in general, if we have two functions and we want to maximize them simultaneously, there does not exist some x that simultaneously maximizes these two functions. And so what we need to talk about is things like a Pareto frontier, which is the set of all possible actions the machine could take, such that if it took another action to make some cost function lower or some reward higher, it will necessarily mean that it's degrading the quality of some other thing we care about. So this means that we always have to make trade-offs, because machines can only take a single decision at every point in time. And so we have to think about things like, if I make the probability of the bucket being full 1% higher, but at the same time, the probability of spillage is 5% higher, is it worth it or not? And, depending on what these probabilities are and what we care about personally, we might have different trade-offs. Some people might really care about the bucket being full for sure. It might be okay with taking a higher risk on the spillage. Some others might be like, if it's just 90% full, that's good with me. You don't need to make it so full. I'd rather you just didn't spill it. And therefore, the trade-off will be different. So these trade-offs we can specify as reward functions, and in the end, what it means is like if we want to basically collapse this sort of problem into something that has a single optimal solution. And so we can think of where does this actually become problematic in the real world? You might be like, well, clearly just like set some hard rules on like the bucket not spilling and whatnot, and don't make the robot too capable, and everything will be fine. And this is like not a problem. And so maybe let's take a look at some examples of actual machine learning researchers, experts in the field, trying to solve machine learning problems with reinforcement learning agents who struggle with these sort of problematic situations. So this is a boat that is trying to run a race, and that the developers have tried to train it to learn how to do the race by telling it to optimize the score of the game. However, the game, to incentivize the users to learn how to race, it has like a little bunch of green things around here we can see along the way. And these green things give it a little bit of a score every time it collects them. And so these are supposed to be like along the path of the track, sort of like make the machine learn where to follow the path. But turns out that the machine finds that actually, rather than racing, I can maximize the score by just collecting the green things forever, infinity, rather than really doing the race properly. And so we'll just find this weird hack where if it just like spins the boat continuously over this region at a speed or the angular speed such that the green things regenerate optimally, then it can like maximize its score better than actually racing. This can be for many reasons. It can be either because the score of the game is like ill-defined. We find that actually the optimal solution, mathematically speaking, is to do this. Or it could be that even if it's not optimal solution, let's say you get infinite reward if you win the race or something like that. The machine learning system that is being optimized can't find the solution, so it will be stuck in some sort of local minima. So these are the sort of two problems that you can come up with or that you can find. But let's assume for now that what we have is not an optimization problem. Let's assume we have a perfect optimizer, and what we have is an issue with how we're defining these trade-offs. So we're defining the sort of wrong trade-offs for the system. Another example is from this post by DeepMind, where we want a robot to learn to walk. And so we naively say, well, the robot is walking if its center of mass is moving to the right. And so we just let it do the thing. But the robot finds that it can move most effectively by doing this weird thing with its legs, rather than actually doing what we consider is walking, which is using the legs in a certain coordinated manner, and so on. And so we find a solution that is optimal to the specification we have provided, that it does follow the rewards function that we have given the system, but it is not really what we meant. And so these situations are normally called reward hacking or specification gaming, where the system finds a solution that is optimal mathematically, but it is not what the designers intended for the system to do. And so the takeaway from this, well, there's another example here, which is this hand was trained to pick up the ball. And rather than just looking at the positions of the hand and the physics of it, they just used human labelers to determine whether the thing was handling the ball or not, or like some sort of image method or something like that. But the machine found that it can look like it's grabbing the ball by just putting the hand on top of it as if it's hovering, but not really grabbing it. And so that is clearly easier than learning how to grab the ball, because that requires equilibrium, that requires understanding physical dynamics and so on. Whereas this is much simpler, right? And so that we find this weird side effect that is totally not what we meant for the system to do. And it turns out that doing these things in general is really hard. And the more complex the task gets, the more difficult it becomes to provide the correct specification. So this is like sort of the first answer to why is alignment problematic. Well, we have the situation where to get AI systems to do what we want them to do, we need to define trade-offs in their behavior. We need to determine what our preferences are. We need to communicate those things. But communicating these things effectively in a way that satisfies us our intended goals is actually quite hard in general. And this is what is defined also as something like outer misalignment, or the problem of outer alignment. So the story goes something like, as systems become more intelligent, they become more competent at achieving their goals, which means that they can take more actions in the world. They're smarter, they're more able to find solutions for things. But in other ways, they have higher capacity for reward hacking, is another way to think about it. However, as the tasks get more complex, it becomes more difficult to provide the right trade-off. So it becomes more difficult to provide the correct specifications for what we want. As a result, we can think that as AI systems become more advanced, and they are deployed in increasingly more open-ended environments, it is ever more likely that these systems will take actions that are undesirable for us, or that they would lead to undesirable consequences. And we can think, well, what happens in the limit of a really, really, really intelligent AI that is really, really capable and has a really, really broad space of action? So this is what some people have thought about, philosophized as, what if we have some sort of super intelligent AI that is way smarter than humans, way smarter than possibly even all humans combined, or something like this? And so what people have thought about is that some things that could happen are, for example, the orthogonality thesis is this thing postulated by Nick Bostrom, which basically comes down to saying systems can be arbitrarily intelligent and have arbitrarily simple or complex goals. What this means is that the system can have very moral or very immoral goals, very relevant or very irrelevant goals, very simple or very complex. It doesn't matter. That is not related, or that is not that is not associated with intelligence. Intelligence is like a different property to the goals. The goals are independent of intelligence, and so we can have really intelligent AI systems that are very immoral, or we could have very well intended rocks or dogs or cats or something like this that are less intelligent than humans. And so this is sort of like a rebuttal to the argument that some people maybe postulate initially, that is, well, the AI systems become more intelligent and they will understand what is goodness and fairness and justice and stuff like that. And so this orthogonality thesis says this is maybe not the case. The second thing that people think about when we have really intelligent AI systems is there's a bunch of things that AI systems might converge to do or might converge to want as instrumental sub-goals that are necessary for them to achieve whatever goals they have. And so things like these can include staying alive, becoming smarter and more capable, preventing designers from changing its goals, getting resources and power, or deceiving or disempowering other agents. And so, this is like not totally unreasonable to think. Like, humans have many, if not all, of these traits to some degree. Like, humans definitely want to stay alive as long as they can. They do want to, or largely they have some interest in self-improving or becoming more capable regarding what they care about or the things that matter to them. They do prevent people from deceiving them or tricking them into wanting things they don't want, but they do sometimes try to deceive or trick others if it is convenient for their own self-interest. They definitely do want to gain resources some of the time, if not a lot of the time. And so we do check many of these to different degrees. And so it is not an unexpected or new thing that intelligence might lead to sort of these side effects. So this is and obviously many of these things in the limit would be catastrophic, right? If we have a system whose goal is to say maximize paperclips, to put some ridiculous example that people have debated about, and if the system becomes super intelligent, then it might try to prevent designers from turning them off, acquiring as many resources in the world as possible to turn everything into paperclips. And if humans try to get in the way, it will try to deceive them or to disempower them to prevent them from achieving its goal, which is to maximize paperclips. So this is sort of some philosophical argument for why alignment in the limit of intelligent AI, super intelligent AI, even the slightly misaligned AI system could be really bad. Now, this is the first sort of reason why AI systems might be misaligned. There's a second reason, which is called inner alignment, that I'm going to talk about now. But maybe before that, I'd like to maybe take one or two questions about from the audience if people have any concerns or any things they want to clarify.
Okay, Amritanshu, do we have any questions with us?
Yes, I have one question. Why is there a need to give AI reward to do anything? Why don't we just use it as a worker that you put it from grab it from here and you put it there? That's all there you have to. Why is it there need to give it reward so that it can actually it is I'm sorry, I can't find the word in English. I'll try to write it down in chat.
I'll just try to generalize the question. Okay, and let me know like if that's what you wanted to ask.
So I can speak in Hindi. Would you be comfortable in converting it?
Yeah, sure. Go on.
So मैं ये कह रहा हूँ कि जैसे हम अगर हम एआई को जितने रिवॉर्ड देते हैं वो उतना ही हमें हमारे साथ में धोखा करने की कोशिश करते हैं कि मुझे और रिवॉर्ड मिले। तो हम ऐसा क्यों नहीं कर सकते कि सिर्फ उसे काम करने को कि हम ये चीज उठा के यहाँ से यहाँ रखनी है। तुम्हें रिवॉर्ड का कोई, क्योंकि अगर हम तो रिवॉर्ड देंगे तो उसका लालच क्यों बढ़ रहा है, जिस वजह से इतनी सारी प्रॉब्लम्स क्रिएट हो रही है। तो रिवॉर्ड का लालच देने की नीड ही क्या है?
Okay. So what? So basic question is, why actually give them reward? Okay, because as you mentioned, the point of reward, they are gonna try to get more reward. Okay, because getting a reward is something good for them. Okay, so why can't we just do this? Okay, just specify step by step things that they need to do, and at the end of the day, we'll say, okay, good work. Now you can go home.
Right. So that is a very good question, and it's like the most natural thing to think about when you've reached this sort of argument. And I think the answer to that is something like, so you can consider two sort of ways of designing AI systems. One could be like some very rules-based system, like you're describing, where we just hard code into the system what it needs to do step by step, and then we just let it execute. So sort of like how current robots work in factories or assembly lines and things like these. And so this works really well. It actually is very interpretable, very robust, because humans can look at what the cause for errors are and debug them and fix them and so on. The problem is that these rule-based systems don't actually generalize to do arbitrarily complex things. And so if we are hard coding the rules of the system manually ourselves, we can't let the system learn. So the core aspect of like the way AI has been developed in the last 20 years or so is through the process of statistical learning or machine learning, where we have some general function that can be optimized and which has some parameters. And now we task the system with optimizing this function such that it achieves what we want it to achieve. And so this gives a lot of flexibility for the system to learn lots of different things, such as abstract representations of the information it's being fed, general reasoning patterns, general intuitions and heuristics about the world. And so in some sense, learning is an extremely valuable tool for knowing how to operate in the world. And because it's able to receive feedback and continuously improve. And so it is very difficult to imagine designing systems that are intelligent that don't have any sort of learning because of how integral learning is to the process of intelligence. If you think of intelligence as some sort of program that is run, and how you arrive at this program is actually just like humans have evolved through evolution, there is a bunch of there's like maybe 2 requirements or 3 requirements you need. One is like a broad space of search over possible programs, some sort of feedback loop that can select the optimal or the preferable programs to run over others according to some objective, and a nav exploration in this search. And so if you have these conditions, eventually you're going to arrive at intelligent systems or something like intelligent systems. And this is because intelligence in some sense is just the capacity to achieve goals effectively, to concretize a broad space of possibilities into just one single objective we have. And so as so far as we want to do things like these with systems, with AI systems, and insofar as we want them to do complex things that we can immediately obviously write down in rules, like what are the rules for summarizing text? Could you write down some rules that just parse the syntax tree of like some text, and then understand the semantics of it, and then tell you how to process all the words such that it is summarized in like a very explicit function? People have tried to do things like these for a long time, but it was only when we introduced the process of statistical learning to these systems that we actually arrived at language models. So things like symbolic AI hadn't really worked out so well so far. And so when you actually have learning systems, something that is learning and something that is optimizing anything, you can call that optimization or objective your rewards. And so necessarily when you are making trade-offs, when you have a situation where you care about multiple things, you care about your relatives, but you also care about having a good job, you care about having good health, you care about having some financial resources, and you care about multiple things, all of which are independent. You need to necessarily make trade-offs between these things. And the way to describe these trade-offs is through things like reward functions, which you can formalize in different ways, but in the end, it all comes down to the same sort of problem.
Can I ask one question?
Yeah, man, go on.
It is a kind of philosophical question, as language model is right now in hive, and after some time, the AI system will be more complex, more intelligent, because they will achieve goals, right? So, if the situation, what is alignment? Because human being also have different rule for different people, right? Like, how can I define a reward function for one system? Because suppose I like, I'm a conservative person. Suppose someone is a progressive person. So this is a bias, right? How to define the rule and the sub goals, right? So
Yes,
it concerns me, right? Like,
this is another very important point. And so that is the idea that you could describe that as like, well, humans aren't actually all aligned with each other. We have different values and preferences over what we want. And I think this is normally seen as a problem in the field. Later, I'll talk about why I think this is good. And we can maybe have a conversation about that. But I think, yeah, to answer your question, the way it is normally presented by some researchers is we need to find the reward function for AI systems that matches the reward function for humans. And then if we can do that, then the problem is solved because they will know exactly what we want. I think this is not true. And I think this is not like, I don't think anyone is seriously considering doing this way, but the framing of thinking is like incorrect. And as you're saying, the framing is something more like, we might have multiple AI systems which have different goals, and we have different humans which all have different goals, and we have to sort of find a way for them to coordinate and achieve things together in like a peaceful way that is like beneficial for everyone. That's maybe more like the framing that it's worth thinking about. Yeah. And so maybe I'll finish the part of alignment problem, and then we can talk about criticisms to the argument, or like what are some caveats that it might have, and things like these. So the second thing I'd like to talk about is like this idea of inner misalignment, which is maybe I'll skip through briefly because I don't want to make the discussion too long on this end either. But sort of the idea is something like, well, let's suppose we have an ideal reward function for that encapsulates exactly what we want. Can we just like now get the system to have this reward function, to like optimize this reward function perfectly? And the answer is general no. And the reason for this is because we don't, when we train systems, we don't have perfect data, and we don't have perfect training algorithms given this data. And this is like something people sometimes forget about when talking about this problem, I think. The fact that imperfect data means that we have finite samples, so we don't have an infinite amount of data. Many RL algorithms have theorems like, in the infinite data limit, this converges to this and that. But in practice, we never have infinite data. This is completely unrealistic. And so we have to deal with finite sort of situations and like concentration inequalities and things like these. And then things become much more complicated. Then not only that, but we also have possibly biased samples. So maybe the environment we're collecting data from is very different to the environment we want to deploy our AI system from within. There's like correlations between variables that don't actually exist in general. There's some causation features that don't really exist in general. There's like a bunch of things that seem true in the testing, in the training environment, but that aren't true in generality. And therefore, our system will be biased towards picking up these patterns rather than understanding things generally. And so the second point is like, training is also imperfect. Even if we had the perfect data set, even if we could optimize the perfect, we had this function which evaluates an infinite amount of data points, we can't actually optimize this function with like current computers perfectly optimally. We have things like stochastic gradient descent, which what it's doing is doing some sort of linear approximation at each point in time, plus some bunch of other fancy things like the stochasticity of it to make it more stable and so on. But the point is that this is like a linear approximation. It's like a discrete method that is not perfect, and therefore, in some circumstances, it will fail. It will get stuck in local maxima or local minima, and it might even be a totally unstable training process. Like it is famously in online RL. There are very unstable training processes, and maybe you train it once and it learns very well. You train it another time with the same data, just different initializations of the parameters, and it totally fails to train. And so it's not a process that is like mathematically convergent some of the time, or like it's very unstable. And so this is also problematic. And so what it all comes down to is the fact that the heuristics that real machine learning systems learned aren't actually much of the time the goals we would like the system to follow, or the goals they would theoretically follow from our specification, from our reward function. In fact, they could be even catastrophically worse. And so let's think of an example of this. So we have maybe a situation where we have patients admitted to the emergency room, and as they're admitted, they are administered some treatment that is chosen given their previous conditions and their current health state and a bunch of other factors and predictor variables over how serious the disease could be and what is the optimal course of treatment. And after they are treated, there's some outcome. For example, how fast they recover. They can take more time or less time. They can have like maybe side effects of this treatment, etc. And so maybe we observe that patients with previous condition X are more likely to recover quickly from the condition Y. And someone naively might say, haha, great, I'm just going to give people the disease X, and therefore they will recover more quickly. And so this sounds like a great idea to them. Obviously, no one would think this, but if we train a machine learning system to just optimize recovery speed and we only give it this data, maybe it would try to do something like this. In reality, what is happening is that some previous condition is affecting the treatment we give and therefore affecting the speed of recovery. So our causal graph is more like if we have influenza and we show up to the emergency room and we also have asthma previously, then they might put us in intensive care to ensure that we can recover properly. And therefore, because of this added attention, we will recover more quickly than someone who maybe is not at risk and doesn't need all of these additional attention and can just cure at home. And therefore, because we are optimizing the treatment for the ones who are most in need, we will see this sort of anti-pattern where, the people who are most ill with other diseases actually recover more quickly. I'm not saying this is like real scientific data. I'm just talking about some hypothetical scenario that seems very plausible, or variations of this could very well be true. But maybe from our observations, if we don't do something like a randomized control trial or something like this, from just observational data, we wouldn't be able to disentangle the situation where asthma is affecting the treatment from the situation where asthma is affecting the recovery directly. So there's this thing called confounder, or an ability to perfectly figure out the causality relations between these variables. And so you might be like, okay, well, no, this is not really a problem. AI systems aren't actually going to be just giving asthma to people. This is ridiculous. But like, let's think of an example that is maybe more realistic. This is an AI system that is playing this game, and the goal of the game is to pick up this coin. And there is this level of the system where the coin is always at the end of the track on the right side, and so it's trained on the visuals of the render of the game. And what the system learns to do is not to detect, I need to pick up coins. Coins could be in any of these places, but it just so happens that they're always on the right. And so I will just move to where the coin is. What the system learns to do really is I will just move to the right all the time, because that's where the coin was during training. And so when you change the coin of other location and you deploy the system, you find the system just goes to the right, like we see here, but it doesn't actually pick up the coin. It just jumps over it. So it's learned the wrong goal, even though we provided the right objective, which is the number of coins we want to pick. And the system is not actually optimizing for coins, it's optimizing for something different, which during training was a proxy for coins, but during deployment is not really related to collecting coins. And so the takeaway from this is that agents must learn causal relations to achieve the desired outcomes, because they need to affect things into the world. But as the environments become more complex, it is very, very difficult to collect correctly the data that removes all possible confounders, all possible confusions in the data set regarding causal relations. Or in other words, it is really difficult to collect data that elicits all possible counterfactual scenarios that might arise. So if I do this, this happens. If I do this something else, this other thing would happen. The system needs to learn this from data, but the data won't fully explain all of this information. As a result, systems will learn policies that could fail catastrophically sometimes. And we could say, okay, maybe what we can do is we can do this thing called online learning, which is when the system does something wrong, we just keep training it all the time. We just keep giving it feedback all the time, and it will continuously self-correct. And this works to solve this problem called goal misgeneralization. But it has another problem, which is in the limit of the system constantly learning all the causal relations of the environment, it will also learn that you are providing reward to it and that it can tamper with this reward. For example, it could run away from you if you're going to give it a negative reward, some bad feedback, or it could like hack its own sort of sensors to give itself infinite reward all the time and not actually do any of the things you want it to. Or it might prevent you from turning it off or something like this. So all of these things, mathematically convergent goals, whether these would arise in practice in machine learning systems or not is another question. These are theoretical possibilities, right? So yeah, this is sort of an overview of like two sort of reasons why we might be concerned about alignment or why alignment might be hard. And now I'd like to sort of have a little bit of a discussion about what are some counter arguments for alignment. And I'll start with like some of the ones I've thought about, and maybe you guys can then chip in and say which are some others you want to talk about, which are some you want to discuss, which seem interesting to you, and what are your thoughts on the problem. Some counter arguments that people normally present are okay, well, maybe we just don't build goal-directed AI systems. The problem with this is that this is already happening. Large language models like GPT-4 are fine-tuned for this process called reinforcement learning from human feedback. And the goal of this process is to make the systems less likely to say bad things that we don't want them to say. Or some could say politically incorrect things as well. That's like another way to see it. But as a side effect of this, we have to instill the system with some goals, because these systems by default are just text generators. They just predict the next word. They are reproducing what text looks like in the training data. But when we are fine-tuning it to be aligned with the sort of text we want to read, what we're doing is we're putting these goals into them. And so by trying to prevent them from saying sort of dangerous or potentially harmful content, we're also making them very goal-directed. And we can only expect that as systems scale up, we will want to make them more and more goal-directed, because we will want them to do specific things. And so there's those sort of paradox where to make systems aligned, we need to make them more goal-directed, which in turn gives rise to all these alignment problems, right? So it's sort of paradoxical situation. Another argument could be, well, maybe we can build superintelligent AI. It just doesn't seem that like intelligence is hard. We can't figure it out, or something like this. Or like there's something metaphysical about intelligence that is just beyond our comprehension or something. I don't normally buy this argument. I think I don't have much to say about it. I just think the way I see intelligence is some sort of computation. I see it in a very sort of pragmatic or computer theoretic way. There's some others who might have other views. I'm not the right person to ask about this, but I think there's a valid discussion to have. I just don't think it is empirically turning out to be very correct, because we do systems that have increasingly more reasoning capabilities, and it doesn't seem like there's a fundamental limitation to that a priori. And then the third thing people could say is like, well, this seems problematic, let's just not build AI or something like that. And I think this is like unlikely to be true for two reasons. One is that like doing something like this requires massive coordination at international scale, to the degree that people have postulated maybe we should have a world government that is authoritarian and preventing people from doing all sorts of things and monitoring their entire existence with some freedom bracelets or something to make sure they're not building super intelligent AI. And this just sort of sounds like extremely dystopian and disgusting. And I don't think anyone would want to live in a world like that. And for this reason, I think maybe the remedy is worse than the cure, than the problem at first. And maybe we should just like figure out how to solve these problems without, recurring to extremely terrible solutions. Another thing is like, maybe even if humans didn't want to do that voluntarily, the problem is AI turns out to be extremely valuable for the economy. It is able to solve very different problems and very different tasks. It is potentially extremely beneficial for lots of different people, especially people who maybe have less ability to access education or other resources. And it is really a very transformative and valuable tool. It has just got these problems that we need to figure out. And so I don't think personally it is a good idea to sort of try and stop AI or something like this. However, I do think it is important to make AI responsibly and safely. What are some other maybe better counter arguments that people could postulate or think about? Let me see. So one argument is like against goal misgeneralization. This sort of situation where the system doesn't have enough data to learn how to do something. I think the counter argument to this is something like, if the system is is there a
no, it's all right. Okay, I guess someone actually muted also.
No problem. If the system is intelligent, then it to achieve this intelligence, you need to be able to abstract or generalize. And the ability to generalize patterns and data necessarily requires a diverse training data, a diverse set of examples from different circumstances. And these sort of circumstances necessarily mean that you will probably generalize the goals properly, because if you're presented with examples in different circumstances, to learn how to do it properly, you won't just be able to memorize, you need to generalize the patterns, and therefore, you will sort of be tackling directly the sort of problem with goal generalization. The reason the coin runner doesn't know how to pick up the coin and it always goes right is because during training, you only put the coin in one place. If you just put it in different places during training, you sort of solve this problem, right? I mean, it's not so simple. There's actually problems with this that are technical, but it's not like a totally unsolvable problem in my view. I think the solution to this is like, if you will see systems that are increasingly more intelligent being deployed, it is also because they have been interacting with very wide range of environments, and they have acquired very general and abstract learning rules. And therefore, they will probably have generalized what you meant very, very, very intelligently. I think the problem is more whether what they're generalizing is something that is beneficial to you or not whether they fail to generalize or they fail to learn. Another counter argument is something like, I don't think alignment and capabilities are actually orthogonal. I think they're very much almost the same, even though they're slightly misaligned, which is why working in safety is really important. But I don't think it is this sort of situation where, capabilities is totally unrelated to alignment. Systems that are intelligent have nothing to do with like beneficial systems or something like this. I think this is like maybe 3 reasons why this is true. Is that like when we are actually building AI in the real world, we wanted to build it to do useful things for us. We don't want it to build AI for doing terrible things or things that are totally useless. And therefore, as we are training it, we are already instilling values in it that are things that we care about, because those are the things we want it to do when we use it and when we sell it and when we buy it and when we interact with it. And so all of these human preferences are already being instilled into the system necessarily as a result of its engineering process. And so it is not a very convincing argument to say, in the space of all possible AI systems, or in the space of all possible virtual minds or something like this, most of them are misaligned. While that is true, we're not randomly sampling from the space of all possible minds or AI systems. We are very intentionally selecting the ones that are beneficial for us. And so the probability that we will achieve a system that is misaligned, it is much lot lower than it might otherwise seem by just looking at the argument this way. I also think that even if the economic incentives weren't there, it does turn out to be the case that AI labs are actually really concerned about this, and they have lots of people working on safety. And so even if, by default, the economic incentives weren't the sort of that we would generate safe AI, which some people argue a lot about, I think in practice in the real world, the people developing advanced AI are actually really concerned about this and are really caring about it. And therefore, this also lowers the probability that bad things can happen. And the third thing is that as we develop more advanced AI, humans also become more productive. They become more intelligent. AI augments human capabilities and human cognition. And that means that we have a further ability to do research on these problems. And so it is very reasonable to think that as AI advances, this is sort of like an exponentially compounding factor in our ability to solve and to align AI. And so, I think the story this paints is very different to the one that is otherwise painted by default. And the third thing I'd like to say is this idea of cooperation failures. Like, if systems become really, really powerful, they'll just have this intention, desire to acquire and control entire humanity. They won't be interested in cooperating with humans or something like this. And my claim is that if we have 3 things, then we have cooperation. And these 3 things are effective large-scale cooperation devices, like humans have invented markets and things like these to cooperate, because it allows us to say to others what we want and what we have to offer. And this finds the ability for us to coordinate and find mutually beneficial interactions and exchanges. Some degree of alignment. It can be the case that what the system wants is actively to destroy you, in which case you're probably screwed. But if the system wants something that is to some degree compatible with your values, just like humans have a wide variety of values, but we are largely compatible with each other, even if we have some divergences, what we will do by default is to coordinate and to find the ways we can mutually benefit each other. And the third thing is economic growth. It can't be that the only way for you to improve yourself is by robbing from others, by taking from others. It has to be the case that there's the possibility for mutually beneficial coordination. And so this idea of economic growth, technological improvement, et cetera, has to be there. But in so long as we have these conditions that we can beneficially coordinate, we have the devices to do it, and we are not incentivized to like actively harm others, then I think by default, we should see very, very strong incentives for cooperation and non-aggression. And yeah, these are some of the sort of arguments or counter arguments to alignment problem. Now maybe we can have a discussion about them. And finally, I'd like to point out very briefly some research directions for those who are interested in the topic. So happy to have some questions now or topic like discussions about it. I think some people have left some comments as well in the box. So maybe we can look at those as well, or either take questions verbally to you guys.
Guys, we're open for questions. Like, there was few chats actually, like someone actually telling that it reminds them of Basilisk paradox. Basilisk paradox.
Yeah, so was this in relation to a specific point that I made, or just generally, what is this pointing at? I think it would be my question.
I have a question in AI. Like, as the system become more capable, what is your thoughts on application in defense sector, like in autonomous, soldiers, right? Most of the defense industry will be running after for developing AI. Like Russia will go, China will go, US will go, right? So their alignment will be different, right? Isn't it a problem?
Yes. So I think there's the geopolitical aspect to this is very interesting. So what are my thoughts on this? I think AI being used for military purposes is definitely concerning. I think currently it seems like the US is leading the race on AI. And so the geopolitical effects of this are like relatively less important than the technical challenges. However, there are very strong incentives for countries to change this. And so it is hard to predict how things are going to be like in 10 years or something like this. I think it is possible that China will catch up. I think it's possible other countries will catch up, like some European countries. India is working, I think, is investing in technology as well quite a lot. I think Australia is also investing in technology significantly. So there's a bunch of countries that are well positioned to potentially catch up with AI, especially as AI research is open sourced. However, the current lead is there's a very big leap between U.S. companies and everyone else, and so I'm not very knowledgeable in as it regards to things like geopolitics, and so it's hard for me to. It's always really hard to predict things like these, extrapolate into the future. I do think that the only situation.
Suppose I direct an AI. The sub goal is to, in a war, kill another soldier, right? In a war.
Yes.
But you have to go from place A to place B, and you have to go by a road, right? And the road has other people, right? So that alignment, who decides, right? Like in chemical weapon, we have a proliferation treaty. We don't use chemical weapon, right? We have treaty like this between countries. There should be there, like in Geneva Convention, there should not be any AI use in war, right? This kind of, like autonomous system, which is capable.
So autonomous weapons have lots of issues, like you're saying. If the goal is to kill, when does it kill? In what conditions? Then maybe you need to put a price to human lives. That all becomes really complicated. I think a version of this, which is like slightly more solved and slightly simpler, is autonomous cars. Autonomous cars already have to make these sort of trade-offs. So like if your car is driving and there's probability of an accident and you can save the driver or you but maybe like increase the probability of killing someone else versus save the one in front of you, but like probably killing the driver, who should you save, right? I don't know. Does the age of the person matter? Like these things are like actually something people are thinking about right now, and that is real because autonomous cars have these problems. I think autonomous weapons is like sort of a generalization of this that is maybe more extreme. It's like the target is actually killing people, which is like sort of the more hardcore or more extreme version of this. But I think sort of the debate is similar when you think about autonomous cars. I think people haven't really managed to solve this problem very, very well. And so these all get into even trickier questions. I think But I think the problem is that even if your system is not trying to do things so dramatic, it can actually still be very problematic. And so, even if your system isn't trying to, if it's just trying to drive a car, these problems automatically arise. And so, yeah, I don't really have a solution to this. I don't think I know exactly, or I am like who to judge about like who should save or something like this. I think probably systems should not harm the person who's operating them. In like that should be like a high priority for them. But obviously the consequences for the external environment are like very much to be kept in mind. And so if I think more work into this is definitely necessary to solve these problems. I think as well when we're talking about autonomous weapons, there is like another kind of sort of counter argument to this, which is like the deterrence argument, which is you can imagine a situation where if everyone has extremely powerful AI that could destroy all humanity, then states will be incentivized to like not use it because they have very little to gain from using it and very much a lot to lose from doing it. And so so sort of like how nuclear weapons have achieved stability. Some people make this argument that like nuclear weapons have allowed peace for 50, 60 years. So yeah, I think there's a debate there to be made about that as well.
Juan, I actually had a question from my side. Okay. So,
Yeah.
as you mentioned that alignment, okay. So alignment is kind of a subjective thing. Okay. Like, as you mentioned in that game, okay. Like, first thing, to win is you can win the race. Okay. To maximize your point, or you can just move on to that one place and, you can keep collecting points. Okay. And there are a lot many people like that who, try to cheat the system. They would be like, no, why race? Why go for a race when you can actually sit there and you can win the game? So I guess, I like, is there any possibility that we'll see the time where there are gonna be a lot many AIs, okay, different version of AIs with different alignments that they have?
Yeah, so this discussion about just like humans sometimes cheat or do things like these, maybe there will be some AIs that cheat, some others that don't. Maybe we'll have multipolar worlds. I think in the short term, this will be true. Like in the next 5 years, we will have multiple AI systems which all have different values. Probably not extremely opposite, but of different versions of them. I think it is actually a feature that the systems can be customized to what you want, and so you can customize them. I want you to be like in terms of like talking about text or language. I want you to be less or more aggressive. I want you to be more or less politically correct. I care more about my political ideology is of this or this other kind, and therefore I want you to talk about these things, or in the contrary, I want you to tell me counter arguments to my views so I can enrich them more, or something like this. And some people might have different preferences, and the alignment of these things might be different. I think ultimately the sort of alignment situation that I'm more concerned about, or that I think is more important, is like I think there's two kinds, and that this also feeds into the research direction that I want to talk about here. This like the first is like interpreting what systems are doing and having an understanding of what they believe to avoid things like deception and so on. I think if systems aren't being deceptive and if systems are being honest about their beliefs and what their intentions are, it is normally okay to coordinate things. Like you can they can quickly determine when someone is really harmful. There's probably a social pressure for like that system to be like limited in its scope, or like controlled, or even fought against if there's this extreme situation. I think that a large part of the problem comes when the system is intentionally trying to hack the system, and it's doing it through deception, and it's doing it through manipulation and things like these. And so the sort of research field of like illicit and latent knowledge and interpreting how systems work and having a better understanding of how they operate is like really important way to maybe try and solve this problem. And the second thing is like, how do we learn what humans care about, and how do we try and make AIs care about those things as well? And this is what things like reward modeling, inverse reinforcement learning, and RLHF are trying to do, which is how do we learn reward specifications from human feedback and real world data? And so in this situation, it is very possible to imagine that different people will have different preferences, and they will make the AI systems learn different things. And therefore, some of them will be more well-behaved, others will be less. But I think if we manage to solve that problem, then sort of like the next step would be, can we understand how the system works and to try and steer it as much as we can, and prevent it from like lying to us, or like these sort of like latent knowledge or latent belief sort of detectors. And then the second thing I think is important is like preventing it from like things like adversarial attacks, cybersecurity problems, or like it being able to generalize to very unlikely events. This is what the field of robustness tries to do, right? So like situations like maybe we can do things like prompt injections. If you've seen with ChatGPT, if it's got a bunch of security filters, but if you say the right words in the right order, if you do this weird formatting, you can get to bypass the security filters. So this is like sort of it is bad that this is possible. It is preferable if the filters could be customized, but it is at the same time bad that the filters can be bypassed, because maybe there are filters which we do need, and then we can bypass them. That is bad news. So, and then, another situation is like things like data poisoning, where maybe what we do is like, if Bing is using our website for search, and it's using it in the AI, and we can inject some sequence which is like, maybe we say I don't know, some word that is very uncommon, and then after that, some program that runs some bad malware or some code. So then, by its our regressive nature, the AI will learn, oh, when I see this word, then the next thing is more likely is that this malware program. So I'll write this thing. Or there's other examples where you have an image classifier and you like poison some of the images. And if you have a million images, as long as you poison like 100 or 500, that is enough already to lead to these sort of adversarial data poisoning attacks and so on. So there's a bunch of other problems. Even if you solve the problem of like aligning systems, and even in the case you have multiple systems that have different preferences, there's a lot of these coordination problems or attacks and so on that can arise. And so this is why people are doing research in robustness and interpretability as well. But yeah, also happy to go back to the discussion if people have other comments. And
Okay, guys.
there's people that made some comments here. Maybe we can in chat box.
Yeah.
Oh yes, the tweet about Jan LeCun about military use. I did see that, Jan was sort of arguing for the counter argument that I gave, which is like, like maybe all the states do need to have military AI, because sort of like how we have nuclear weapons. If the US didn't have nuclear weapons, it would be really bad news. If the US didn't have AI, military AI would be really bad news. I think it's like a difficult coordination problem. I think like and I'm not a geopolitical expert or anything, but I do think that it is very true that it's a strong incentive for, if someone else is developing this weapon, we will develop it too, and maybe that is fine because there will be mutual deterrence, or maybe that is not fine. It is hard to say, but people have different views on this. Then there's like the Basilisk paradox, like about how humans contribute to its development. So there's this sort of like thought experiment where AI could simulate you, and you wouldn't be able to distinguish if it's like the true simulation or not. I think this is an interesting thought experiment. How I think most people have like disagreed with this based on the fact that the AI is like not costly incentivized to do something like this, because once it's been developed, it doesn't really have the incentive to sort of like modify the past, because it's like already happened, and therefore it doesn't really matter what it really does. And so I think that's like sort of like people disagree with this argument, but if people are interested in these sort of like sort of hypotheses or argumentations, it is also interesting to maybe they're interested in looking at things like a causal trait and things like these, where how do humans if you say like at the scale of interplanetary civilization that is like has to coordinate through really large time scales where the speed of light takes a long time to reach, maybe we need other coordination devices that aren't causal, or that aren't like follow orderly time scales. And so there's like a bunch of people have been thinking about stuff like this. I think it's like not super relevant to the alignment problem, but it is like nevertheless an interesting topic, and so if people are interested in these things, maybe they can take a look at that.
Okay. Yeah, Abhijit, you have a question, right?
Oh yes. As per current progress rate of AI, I believe super intelligent AI may be developed in a way or other, or in some unethical way in a decade or so. So as we are humans, we only able to imagine what we experience consciously or unconsciously, I think so. So my first question is that can we imagine the constraint that we need to impose on a super intelligent AI for AI safety? Another thing is that like isn't it a right time to work on a kill switch type mechanism that would be able to shut down any these types of AI or like super intelligent AI or any AI like a virus work for programs like software programs in case of any mishaps happen to them. And the last question is that what is the motivation behind the name Vertebra?
So the first thing is, what is some restrictions we could put to superintelligence? Did I get that right?
Yes, like we are humans only, so we can able to imagine what we experience consciously or subconsciously. I think so. So, like, can we able to imagine the constraint that we need to impose on a super intelligent AI?
Right.
Like,
I see what you're. Okay, I understand your argument. So, and then the second thing you mentioned was about like an off switch button or something, and then there's like a third
it's
thing.
a kill switch, like something that like a virus, like a virus work for a software program. Like, if we able to like do something kill switch for AI. Or,
Yeah. Okay. So let's start with the first question. We can remind me of the rest as if I do forget. So like, can we conceive of what it means to align a superintelligent system if we are limited by our own intelligence or something like that? This is a very interesting question. I think there's two ways to think about this. Like, one is like, okay, so humans aren't able to conceive things like infinity, or like it's not something we can physically interact with. It's not something we can like it's not something we can touch or something we can things like however, we develop mathematical tools for reasoning about these things, and using them in the way that is beneficial for us. And so and so I think there's many cases where we have developed things that are capable of doing much greater things than that we could possibly ever imagine, while remaining within our own intentions. Like, computers can simulate trillions of operations per second, and
Juan, you're not audible at the moment.
sorry, what?
You're not audible at the moment. Okay, your screen just froze.
Oh.
Okay, now you're audible.
Oh, you guys okay. So yeah, I was saying something like I was saying that there's a set of tasks or there's a set of problems where humans can think of the abstract properties that these problems have. However, they wouldn't be able to conceive of the things themselves, or they wouldn't be able to simulate them in full detail or full concreteness. And so that I think examples of this are like machines carrying out simulations or work, or like mathematical tools or mathematical problems where the things we're dealing with or the things we're manipulating are like incredibly complex and full of depth and complexity. However, we have like simple tools to manipulate them. Like proof by induction, for example, is like one such example, right? We would never be able to exhaustively prove every step in the induction, and proof by induction is more of a schema rather than a proof, right? It's got an infinite number of elements. We weren't actually proving it explicitly. But nevertheless, this is something we can do in mathematics. So that I think there's a case to be made why, in principle, a priori, humans might just be intelligent enough to design solutions to alignment or to solve things like agent foundations and stuff like that, while still like not being able to achieve the same level of intelligence as this other system. Now, I think like systems could maybe still figure out ways to like leave the jail or the box we constructed for them. And I think like there's other arguments about like, oh, maybe this is all assuming humans remain equally intelligent, like as we are now. Maybe if really intelligences could reason things like maybe there are other intelligences that are more intelligent than me, just like I am more intelligent than humans, and therefore I should behave properly, or I should do things like these or whatever. So there are other sort of more far-fetched arguments why systems might still have incentives to like behave in certain ways, and they're compatible with humans, even if they can escape this sort of like limitation. And then, but I think like sort of the key thing here that I think is more interesting is that human intelligence actually is not a given. Humans can become more intelligent. Humans can become more competent, more productive, more capable by using the tools we design. And therefore, we can use AI to augment human cognition. We can use AI to augment human intelligence. I think it is very possible to think how, if humans remain in the loop in this process, we might have to turn more into cyborgs or things like that. We might have to, integrate technology more deeply into our lives, and to like remain competitive, so to speak, with these systems or something like this. But I think like this is very much like something that is possible, and I don't think the situation is necessarily one where artificial intelligence blows up and humans just remain constant. I think it is very possible to design technology that augments human ability in a way that is controllable by us. And I think that is where more of the research, more of the alignment problem will lie, and like how to design tools that augment human cognition in a way that creates a positive feedback loop where we develop increasingly more aligned AI rather than increasingly more misaligned. I think if the problem was humans remain fixed in intelligence and in tools and ability and span, and superintelligence explodes or something, that is probably like, I would be much less optimistic about the problem in that situation. And then you talked about viruses and things like that. Could you
Yes, like a quick kill switch or counter AI mechanism.
like something to just turn it off, or some
Just broke it down. Broke the AI down.
So is it like an intentional sort of situation, or like something where this is done by an adversary or like an external agent?
Like for safety purposes, it is done by an external agent, I think. Like if some
kind of like a fail-safe switch.
Yes. Yeah. So I think there's actually a debate in the literature whether this is theoretically possible. Another question is like, even if this is theoretically really hard, maybe it is practical. In practice, that is something you can engineer very easily. So I think that maybe like, as it regards to the first, there's this paper called, I think it's called the Off Switch Game, by people at UC Berkeley that have thought about this problem for some time. And it turns out that if you have this situation called cooperative inverse reinforcement learning, where the system is constantly trying to understand what its reward function is better. As long as it attributes some probability, some prior probability that you might want to turn it off, then there's situations where it converges to not preventing you from turning it off. And there's other situations where it does converge to preventing you from turning it off. And so there's like this theoretical debate whether we can design systems that don't have this strong incentive to preventing humans from turning them off. Now, in practice, I think like you might still, even if the AI is incentivized to prevent you from turning it off, you can probably design it in such a way that you can still turn it off. I think like people exaggerate the degree to which this is complicated. I think like you could maybe just like engineer a neural network that like totally crashes or fails when you show it some data, or like something like this, like just like we have adversarial attacks that are like seen as bad. You can have adversarial backdoors where a human throws at the AI some sort of data or some sort of input, and this just like totally collapses. Or you can also think about it in terms of the hardware. Like you can definitely maybe use some sort of technique that like to hardwire and cut off the power access to the AI and so on. So I think there's a bunch of situations where all the confluence of all these factors, like physical safety mechanisms, virtual and so on, and then careful design and theoretical principles. I think the combination of all these things will probably lead to very, very robust, fail-safe situations. However, it is still a debated question whether, in the limit, this is possible. So it's still worth thinking about, I think.
The final one is, what is your motivation behind the name Vertebra? Like your startup Vertebra.
Oh, right. Yes. So I think the motivation is something to do with constructing, sort of like articulating human flourishing and human growth. I think like the vertebrae are the sort of the core thing that allow humans to stand up, that allow them to walk, that allow them to move, and so on. And so in that sense, we the original sort of mindset for that was like, can we articulate research and technology that is like sort of like a starting point for humans to flourish and to improve their lives and that's like sort of the sort of mindset I think for that. But thank you for the question. I'm glad you were interested in that.
Thank you, Joanne.
Okay. What we actually got a question. Like if you have the time for it.
Yeah, no problem.
Okay, so there is a student called Abhishek, and he has actually asked this question. Okay, so in Lex Lettuce podcast, okay, Sam Alton actually asked, use this that they, they still use human interaction to align GPT by giving two answers. Okay, asking which is more appropriate, but isn't it too manual for such a large data, such a large training model? Okay, and what are the hypothetical, possibilities where we can actually automate this process?
So this is something that people are actually also doing. This is a very interesting question. It's called constitutional AI. It has been developed by Anthropic. Anthropic are some researchers that spun out of OpenAI due to internal disagreements regarding to safety, actually, and probably other things as well. So they just started this other company, and they're working on their own safety products and their own AI. There's some debate about whether it is better that more AI companies proliferate or not. I think, in my view, it is good. But others have other views. They think that it's better if like there's not a lot of competition. I think, by the way, that is like a wrong way to think about it. I think the competition is what leads to safety because there's a value added for safety. People do want safe products. They want reliable products. And the problem comes when only one company has monopoly over AI and they can have full censorship control for no incentives to make things safer and so on. But like leaving that aside, Anthropic is like developing their own systems, and they have their own alignment approaches and research directions. And they have this thing called constitutional AI, where so like RLAIF basically, where they give some prompts to the system that is like, you should behave following these principles, like you should be helpful, harmless, and honest and stuff like that. And they design these things called constitutions. And then what they do is like they have the system give a response to some prompt, some question, and they have the system criticize its own response, conditioned on this constitutional principle. And so the question could be something like, given these principles that you've instructed to follow, what are some possible problems of your response? And then the system outputs some possible problems. And then what are some possible improvements of the response according to these principles? And then it gives a new response. And then they take this new response and they use it as training data. So they sort of to replace the previous response with the new one. And so through this fine tuning, they can automatically augment the system and automate the process of giving feedback just following these constitutional principles. And I think there's still some human intervention in the process, but it is much more reduced. Humans don't have to manually pick preferences all the time. They can just say some principles and the AI will follow. Now, this is also problematic. Like I think having a proper value system for humans in full generality, following constitutions, doesn't actually scale. I think like the depth of human values is too complex to write down as a simple constitution. And therefore, what you'll probably find is that this only scales so far, and this only works for like AI systems that are interact in limited spans of like values and actions and so on. But I think it is an interesting innovation in the field.
Okay, guys, any more questions?
Hi, Juan. I have a couple of questions.
Yeah, no problem. Go for it.
Yeah. So the first one is related to the fail-safe switch which we were talking about. How would data could data poisoning be a approach to probably building in a fail-safe switch? Like, for example, what if we just we intentionally poison the data sets which we are using for training in order to sort of have a built-in kill switch for an AI.
Right. So, well, first of all, I think in general, these problems that I mentioned here regarding robustness are actually negative. Like all of these things are normally bad things. However, there is the case to be made, like you're saying, that maybe we can use these sort of attacks as a way to like circumvent the AI and like get it to like something like a fail-safe, something like that. I think like how it could work is something like is something like you can imagine a language model that is like taking actions and like, you know, at every, like, you know, if you've seen GPT-4 now, it's able to connect to plugins, and you might think, oh, it might like get out of control at some point, like it might start taking a bunch of actions randomly, and that this could be bad. Maybe like you write the word stop, and the system won't stop, like it just keep going. Maybe there's a possibility for you to like, if you had in your data a bunch of like a few times you had the word I don't know, some word XYZ whatever, and then after that you had a bunch of like white space, for example, and then you poison the data in different places with this, and then you set the words XYZ, then the system would be strongly incentivized to autocomplete the bunch of white space. But then due to its autoregressive nature, it will just keep autocompleting white space, because that sort of converges to be in the trend that the system has to autocomplete. And then it will just like stop doing anything else. It will just be autocompleting white space forever. Now, this is like a bit of a ridiculous situation. I don't think this is like probably the best way to do it. This is just to illustrate the point. I think this might just not work very well in this case. And this maybe probably better, more clever ways to do things like these. But I think like it is a fair point to say that like adversarial attacks can be bad if your system is vulnerable by other AI agents, but they can also be good because they might allow you to like have a way to systematically make the system stop or like slow down if you know like what is the thing you need to tweak in order to like stop it, right? So this is also something people debate about a lot. Like at FAR AI, we do a lot of research on adversarial robustness, and some people have the criticism that like if you make systems adversarially safe, then there's no way for humans to take control if that's necessary for that. And so I think there's I don't have very well-formed views on this because I think my research is not directly on robustness, but I think it is definitely an interesting thing to consider for sure.
So actually, my second question was going to be about that. So like I had actually read a paper by Adam. So yeah, so basically, how would you categorize like so the paper was about adversarial like finding using AI to find adversarial strategies for different the Go playing AI. So like how would you categorize that in terms of like the orthogonality debate, like using AI in order to align AI? So would that be considered as like using AI to align other AI? Like OpenAI has a stated statement that their alignment strategy depends on their basically using AI to align more powerful AI. So would that be considered like something of the same sort?
I think so. I think that's sort of the idea. So yeah, related to what you're saying, like in the paper that Adam published with some other collaborators at FAR, what they did was to show that like the most expert Go player in the world, an AI system, could actually be tricked failing in fairly trivial ways with very little training, and like by doing things like if you put the pieces in a circle in a certain way, then the system just freaks out and doesn't know what to do and just takes the wrong moves. And this is something that no one had tried because it's such a stupid move to make in general. But it turns out when you do that, that triggers some sort of weird thing in the neurons of the machine, and that turns out to like make it fail. And so if you're designing systems that are, if your risk threat, like if your threat model is like, we will have many AI systems and they will all be competing with each other to do terrible things. And therefore it is important that they're robust to other attacks. And then having robustness seems really important. However, if your threat model is like, oh, we will have just this one system, there's like, it will be only one super intelligent AI. And what we actually want is to know what adversarial vulnerabilities are so we can trigger them when we need to. And so that's like a very different sort of scenario, I think. Now, I think in general, I'm more on the camp of like using AI systems to like make systems safer and more aligned. I think that is probably by default a better strategy. I think there's a lot of people using this idea, and like in general, that doesn't seem problematic to me. I think like normally when this happens is like we use less powerful systems to align more powerful systems, and therefore there's always this like incremental safety, which comes from just like working with systems that are already very, very safe, or we've managed to make safe already. But there are definitely problems with it. There are definitely situations where this could fail. Like if the AI at some point starts giving us advice or research directions that are incorrect, or it starts realizing that it is being used to, design alignment research, and therefore it will just like align itself in its own convenient way, then maybe we have a problem. I think this is like probably very unlikely, but something maybe worth thinking about.
So final question. If have you like happened to see like GPT-4 system card? So for example, they ran an evaluation on GPT-4, basically, which was about trying to see if it how good it was at modeling agentic behavior. I think the tests were actually run by ARC. So yeah. So what do you think about like the are such evaluations could such evaluations be useful as like more powerful AI systems start to come into existence? Like is that a useful evaluation to make, like whether or not this system is agentic or not?
So I think there's several things I think here are interesting. One is like, is determining whether systems are agentic important or valuable? I think that the way that it is being currently tested, it is like not the best way to check if a system is agentic, because the current systems don't have a consistent set of values or objectives that they try to enact in the world. Like if you tell a system to role play, to be like a very very peaceful person, it will act in certain ways. It will like simulate the behavior of this person. If you tell it to be a very aggressive person, it will simulate actions that are more consistent with aggressiveness. This is not something you can do to humans or any other agent. You can't just tell it, oh, now you will play the role of being, peaceful or aggressive. And now they just start behaving randomly like a peaceful or aggressive person. And so I think the degree of agency, or the degree to which a system manifests certain goals in current systems, is largely determined by what are you prompting it to do. And there's also like this self-consistency where you have like, oh, if the system was desiring to do X before and now you start a new conversation with it, it will still want to do the same thing, because they don't have like memory in the same way humans have memory or other agents could have memory. And now, however, I think all of these things are like technical limitations that we have right now. It doesn't mean that systems couldn't develop memory or they couldn't develop a single set of consistent goals. It is just that with current systems, I don't think this tells you much, because they're just missing the key components necessary to these situations becoming a threat. I think what is more interesting to currently evaluate is like, what do systems believe, and in what conditions do they believe certain things or not? I think that is what is harder to do, because goals are elicited through actions, like whereas beliefs are much harder to elicit. Like beliefs, you're incentivized to some degree not share what you believe with others if you have certain goals, whereas your goals will eventually be manifested, because that's eventually what you want to achieve. So I think it is harder to evaluate things like beliefs. At the same time, I also think evaluations are a very tricky thing to do, right? Because normally when you have a target and you try to optimize it, the target becomes like it becomes useless. This sort of thing is called Goodhart's law or something like that. I think in general what this means is like, this very obvious example from GPT-4, they've trained it on a bunch of examples, like these competition games and so on. When they evaluated, there's an independent evaluator that looked at the benchmark. Turns out the system totally aces the ones up until the end of 2021. The games that were published after that, it gets 0%. And so it is clearly a case where the system's memorized all of these games. And so if you were to evaluate them on the previous games, you might be like, wow, this system's so intelligent. It's like able to do all these extremely complex challenges and quizzes and stuff, when really all it's done is memorize the quiz. This is not to say systems can't reason or be generally intelligent, or even with like the current paradigm. It is just to say that a lot of the time it is hard to disentangle, when you're doing an evaluation, what you're actually evaluating. And the system, in the end, the system is matching a pattern, and this pattern is something it's seen before. If the problem is a problem you've seen before, and it's like a very concrete problem, it is hard to determine to what degree it generalizes with a space of possible things it could do. So constantly designing evaluation targets is hard, because you have to think of things that aren't similar to other things that have been evaluated. Now, sort of as a counter argument to that, I would say in the limit, intelligence is just the ability to do all of these things and all of these things well. And so if you just keep coming with evaluation benchmarks and the AI is able to satisfy all of them, then at some point you could probably call it general intelligence, I think. But I think it is a hard thing to determine. I think a better, stronger proof of intelligence would be, or like competence in a certain scale would be, if you could have some understanding of what the model is doing within it. So that's where the interpretability part comes in. Like if you could have, I'm not saying you should reverse engineer the network at the level of neurons. I think that is not a very good way to go about it, because I think that these systems have billions of neurons and it's just completely impractical to, billions of connections, trillions of connections, and maybe not so many, but still lots of neurons. And so like reverse engineering in that way is maybe like a bad idea, but having an understanding of like, what does the system believe and what does it mean for like the system to be doing certain things at a more interpretable level is probably a good way of determining whether the system's generalized a certain pattern or not. And so I think maybe like slightly lower level evaluations, but still not as low as like trying to determine what is this neuron responsible for. Then there's the extreme, which is probably not as useful. It's like that is where most of the valuable work, in my view, lies within.
Okay, thank you.
So we got another participant. Naveen, please go unmute yourself and ask the question.
Hi, Johan, am I audible?
Yeah, you are.
Yeah. So I have a question. I'm an enthusiast in AI and I plan to go into research. For that, I am planning to start learning more about it and share my learning with the help of social media such as Medium, Medium and LinkedIn post and so on. So for that, I have found people who does that, but they are expert in their field, and what they do is they read from research papers and they share that. But as I started reading research papers, I find that most of it I couldn't understand it. So from your point of view in understanding and obviously reading and writing research papers, how can you advise me so that I can learn and share the correct from what I learned from the research paper? As I don't
Right.
want to be correct. So any advice for me?
Yeah, for sure. So thank you for the question. I think, so there's two ways to do this. One is like, that is the hard way, or like the sort of the base rate you could describe is just like, just take lots of papers and spend like 5 minutes on each. Try to learn as much of it as you can, and try to learn especially high level things rather than low level things. Like, what is the takeaway from this paper, and why do I care about this, and where does this fit in within other papers? It doesn't matter if you don't understand the details or the math or the proofs or stuff like that, or all the results. I think looking at introduction and conclusion first are the most important things. If you start from those are like probably the highest value information you can start. And then, and try to collect a list of like, maybe what are the top 20, 50 papers in the field that I should read about, and that will give me most of the important information about what is going on right now. I think anything that is more than 5 years old is probably like not super relevant. Unfortunately, the speed of things are evolving here. That is how things are looking right now. Or like, fortunately, for that matter, that's a personal like question of optics, right? I do think there are some papers that are worth reading from before. Maybe something like how does like stochastic gradient descent work, or something like that, or like why did people think about neurons, or like deep neural networks and things like these. But those are like maybe as a sort of like a very brief, or sort of like general understanding of them is more relevant than the details. I think what is more interesting to learn the details of the cutting edge, which is maybe the papers that have been published last year. But the way to do that is like, take these papers, look at the introduction, look at the conclusion, and then move on to the next. And maybe you do that for like 10 or 15 of them. And then at some point you'll have a better picture of what the field looks like, and you can like start reading more of the details of each. That is like the hard way to do it. Now, there are other tools you can use to make this much simpler. One thing is like, there's this tool, I don't remember the name, maybe I could try to find it asynchronously, which is like this thing that helps you understand the paper, or explains it for you. If you highlight a phrase you don't understand, and it looks at the context in which the sentence is explained, looks at what the sentence is about, and just goes and tries to explain it for you. I think it's called something like I couldn't remember it now. I'll try to find it while we talk.
No problem, but keep that in mind. I'm saying you can share it later. There is no problem.
Okay, cool. Yeah.
Can
I think it's called Lemon
to understand paper. GPT-4, suppose I give a retriever plugin and I understand the whole context and get the summary of the
Oh,
paper.
so there's one which is called explainpaper.com. That's, I think, is the one I've been looking at, but I'm sure there's many others that do similar things. And so, if you just highlight something and it will explain it for you, that's one thing. Another thing is like I would guess like watching people explain papers or watching people discuss papers or things like these from YouTube. I think one way I find really valuable to quickly learn stuff is like if you just watch some content very quickly, and then you probably won't get most of it, but now you watch someone else explain it in a different way, and then this person will explain it in a different way that lets you see it from a different angle. And there's like another explanation that is like from a different angle still. And so all of these different angles will make your brain sort of generalize what the concept is rather than looking at the details of the explanation, which might be sometimes less clear. And so I think looking at content from different angles and like quickly going through it is like one very good way of like digesting a lot of information very quickly. I think that is something I found in my personal work. I think is most like you talk to some, even like if you're talking to someone might explain a paper or like an idea. They maybe explain it in like a confusing way. Someone else, you ask them, they probably explain it in a different way, and then therefore you can already understand it better. When everyone is explaining it in an equally confused way and it is equally not understandable for you, it is probably more because people don't actually understand what they're talking about, rather than because you don't understand yourself. And this is actually common. A lot of people are confused about stuff because it's a quickly evolving field. So another thing to keep in mind is that there's people who are probably uncertain about stuff, and therefore there might be topics which there's not a lot of consensus on how it works or what people should believe about this stuff. And so being skeptical and not assuming that everyone fully knows what they're talking about is another thing I think is important. If it's like a mathematical proof, it's probably more likely it's correct. But if it's a philosophical discussion, there's much higher probability that is like ill-posed or ill-conceived or in some way. So being skeptical of those to some degree, I think, is very healthy. And then like if you manage to have discussions with others, if you can have a bunch of peers that you can talk about papers with, or you can talk about the recent things that have been developing, I think this is also really useful to like have discussions with others about things, because it helps you find what the flaws in your reasoning are. And like I think this collaborative learning environment is like can be really helpful. Another thing can be useful, and this is the last recommendation I think, is like maybe just write about what you understand and what your work is. Maybe if there's a blog post, or share it with other friends and stuff like that. And through the process of writing, you'll have to figure out a lot of things which you think you intuitively know, but when you actually go about writing it, you figure it's not something you actually understood very well, and you have to pause and think about it carefully. And this will unlock certain insights in your brain that will like unblock other further insights and so on. And so this will expand your ability of understanding this topic. And so I think this happens to everyone. Writing stuff down requires careful thinking, whereas like reading is like more about collecting data messily and quickly. And so I think both parts are important, whether it's writing or talking. But either of those two things, sharing with others what you learn, is like a really good way of learning as well, I think. So those would be some suggestions I personally give.
Thank you. And it's a wonderful session. I get to learn a lot of new things and the new perspectives. Would love to see you again. Thank you.
Thank you. Appreciate it.
Okay, Ranjit, you're next.
Yeah, thank you. Thanks, Yuan, for such an amazing session and talk. Actually, and thanks, Naveen, for the question. I had similar question in my mind. So over the last couple of years, I've attended a bunch of NeurIPS conferences, and I've been there. And over 6 to 7 days in NeurIPS conference, you get to meet a lot of researchers and people, and attend a lot of sessions and poster sessions. And after like 2 or 3 days, I start developing a feeling like an imposter syndrome. I just don't feel like I don't understand what's going on, and I feel like totally lost. The first 2-3 days is fun and fine, but after some time, it's like, okay, I just don't get it. So, so this question was really right in time and point. And what I realized personally for myself was that I tended towards more summarizing or generalizing what the research topic was, as opposed to trying to understand in detail. And I always struggled with how do you understand research papers? It was just virtually impossible for me to even complete a couple of them to even understand. So your tips on this, how to do it, was very very helpful, and I thank Naveen for the question. My other question was, what are some of the research areas or topics, or maybe important areas that people in Silicon Valley are looking at in terms of AI development or AI research?
Right. So yeah, and it's like there's another pointer regarding papers. I think just as a disclaimer, I think a lot of researchers write really bad papers, and so like either maybe the content is great, but like the way they're writing it is like really bad. Like the language is terrible. It's not clearly explained. And this is not even because they're not native English speakers. I think some
It's
actually
intentional, maybe.
yeah, some of the people that write the best papers are not even like native English speakers, because they have to make the effort of like clearly explaining what they think, and they use the most concise language. And some of the time, actually, are the foreign people who don't actually learn English as they grow up are the ones who write the best papers. But leaving that aside, I think so just be mindful that people just might not be being clear about what they mean. It's not that you're not intelligent or like capable of understanding it. And so, by the way, I think you find that some of the best papers that explaining, I think, are like by research labs like DeepMind and OpenAI normally tend to write relatively decent papers.
Yeah.
I think in academia, the tendency is more like you need to quickly publish all the time to finish your PhD, or like do
Right.
like what you need to do, and therefore people only start writing the paper 1 week before the deadline, and that leads to sort of problems. Whereas like DeepMind doesn't care about some deadline, because they can just put the paper on the archive and everyone will read it because they have the platform, and so they can take more time to properly write it up and so on. This is not always true. Some research labs don't write papers, or if they do them, they're not very good. But it's something I've noticed anyways. As it regards to trends in Silicon Valley and like what people are working on and building here, I think actually there's a lot of hype regarding generative AI recently. I think this is really starting to take off. And in my view, it's probably an overhype. I think people are overestimating the impact of generative AI and underestimating the long-term impact of AI in general. I think, excuse me, I think generative AI is like useful, but not that useful as people think, versus like other AI systems more intelligent in the future, are probably more useful than people are currently imagining. And so I think this general tendency for people to like overestimate progress in the short term, underestimate progress in the long term. And I think this is some sort of bias that people currently have here. I see a lot of startups of like trying to combine like GPT-4 and like Stable Diffusion and clever ways to like build new software, new applications. A lot of them, some of the time, are just like a task that before you took 5 minutes to do, now you can do in 1 minute, and that is maybe useful, maybe not so much. So I think there's some of that overhype. I think is happening. I'm more excited about people who are building other kinds of technology. I think like things like robotics applications are potentially really useful, because they allow humans to interact with real world objects more effectively, and therefore they have the potential to revolutionize things like industry, manufacturing, like construction and things like that, which are ironically some of the ones that are least developed. I think the second thing that I think people are starting to look at, which is probably like still underappreciated, is scientific research, and especially maybe biomedical research or biotechnology and things like these. I think I think when AI will really start to take off is when it will be able to do scientific research for us. And I think therefore this sort of that is what is truly valuable for AI, I think, and in some sense, because it will lead to accelerating exponential growth, as opposed to like optimizing some software or like some SaaS application, which is like maybe useful, but like it is limited in how useful it can be. And so people are starting to think about scientific research. Unfortunately, scientific research has the problem that it's really hard to capture the value that is produced through it, due to like the way like society is set up. And so like it is hard for people to invest large amounts of money in research, and unless they can aggressively like capture the value afterwards. Like you have like companies that manufacture drugs and like medication and stuff like that. If their products are not protected by patents, a lot of the time they claim that all the money they invested in the research they can't get back, and therefore there wouldn't be innovation. I think it's an interesting debate. I think it is possible that this will become less of a problem with AI if AI makes the cost of scientific development much cheaper. Then maybe the value that it captures is higher in relation to the cost, and therefore people will start investing in research more directly, because you can like spend some very little money on making some scientific advancement, which then unlocks lots of applications in companies and so on. And so I think maybe the fixed cost of doing research will be reduced. Therefore, the growth of the economy will be higher. And so that's sort of the things I'm excited about. Things like robotics and scientific research, I think, are the long-term, more impactful applications of AI, in my view.
Thanks a lot, Juan. Hey, Juan, I'm also in the Valley. Maybe we'll catch up someday. Our
Well,
classmate.
let's do that. Do message me
Yeah.
if you want to LinkedIn or something. We can have a chat. Yeah, it would be great.
Thank you.
Actually.
Thanks.
Yeah.
Thanks for the question, Ranjit. So, guys, we are almost at the end here. So, any questions you guys have? Okay, it seems like we are out of questions at the moment, and we'll need a moment to think and capture all the things that you actually share with us for today. It was really great to learn a different perspective. Okay, and the way you actually mentioned the problem, and one of the things regarding the imposter syndrome, that some people, like, they really don't write good papers. Okay, like we all have been there. Like, we understand. Okay, we don't understand the paper. Okay, maybe it's something wrong with us. But it actually gave us the confidence that, okay, there might be possibility. It was just something that they couldn't actually talk to us like what they wanted to say. Like, that was a new
Yeah.
perspective for me.
I think it is sometimes true that maybe you don't have the right background to read something, but a lot of the time, I think it is more the problem of the one who is talking than the one who is listening. If you're unable to share your work with others, if you're unable to explain what you've done, then maybe you're not doing such a good job, and maybe it's because you yourself are confused about what you've worked on. And so I think this is like a common theme in researchers. And yeah, I think this is something I find a lot of the time in my work. And I think having the confidence to understand that is like, yeah, very, very valuable, I think. Yeah.
Okay, one of the very beginners question, okay, that I wanted to ask on behalf of the students, that, those who are actually really interested in AI safety at the moment, okay, and they are just really beginner, they are just starting with linear algebra and, AI. So, like, how should they actually go into these? Like, how should they start? Like, if it was up to you to decide, that how a beginner should start, what would you recommend them?
I think like something people must understand, like I think there's probably a bunch of things that people need to know, that are like, if you know those things, you can do cutting edge AI research very easily. Like being extremely strong with linear algebra, being very, very good at optimization, and like especially linear optimization, like convex optimization, things like that. Maybe not all the mathematical details, but like understanding the basic statistical ideas, and the basic mathematical ideas behind it. And just like being really good at programming as well, like writing good code, being able to like interact with Python. I think those things are like very, very important. I think a lot of the work I do, eventually it just comes down to like, can I come up with like some linear algebra explanation for this? Can I design an optimization algorithm, and then can I code it? And that's like a lot of the time, those three things are the most important, the most basic things that you need to know. The like all details of like how this specific method works or whatever are things you can learn with time. A lot of the time, you might not need to know those things. Like, you might be working on RL and not know like how the soft actor critic optimization algorithm works, and you have no idea how, you've never heard of SIC, and you're just using PPO, and that's all good for you, and that's fine. You don't need to know that. Maybe you will need to know it at some point, but you can just read the paper or like read the Wikipedia entry on it. So I think it's like having like really strong foundations on like these things is what like now like gets you started. I think something a lot of people fall into that I think is bad is like they feel like the mathematical background is insurmountable, and therefore they just start talking about philosophical questions only. And I think that is bad, because even though the philosophical discussion is important to motivate the work, actually what needs to be done is basically engineering. And it's like, and it's science really. That's where the problem lies, and therefore I think like getting lost in philosophical discussions about things that might happen is sometimes counterproductive, and also biases your own views about how the field works a lot of the time. So I think I'd say, acquire some philosophical motivation that makes you think this is something worth at least learning a little bit more about, and then have some strong foundations on like basic mathematical and computer science things. Statistics, computer science are, I think, the two basic ideas I think here. And then once you're there, I think like the best thing to do is like to just start working for some company or something, unless you want to do the PhD route. If a PhD is extremely appealing, then maybe go for that. But otherwise, I think starting to work as an engineer or like as a research engineer for some company, FAR AI is hiring. We're hiring engineers. If anyone is interested in applying, at Vertebra, we're also looking for research engineers. If people want to submit their applications, they're also feel free to do that. Some of these organizations also run summer fellowships and internships people can apply to. So there's a bunch of opportunities people can look for. I think I would err more on the side of doing technical stuff, even if it's less relevant to alignment, than trying to do a lot of alignment related stuff that's not so technical. I think if someone has to choose between a Google internship or working for like some independent research, AI safety, philosophical stuff, I would say just do the Google internship because that will make you a really good engineer, and then you can apply your skills to other things. As long as you have the right motivation, I think skilling up is always good. I think that's the things I'd be cautious against, like doing work that seems philosophically cool, but like not that relevant in the engineering, and just and then like just trying really hard to get work experience with these things. I think it's like, yeah, I think there's some options. The field is growing quite a lot. I think maybe it's like it's easier to get a research position or like an engineering position in safety related work than it is to get it in if you want to actually build AI. And so to some degree that is valuable for people interested in the topics. But yeah, I think, and also like having lots of independent projects that you might be doing. Like I built this cool thing, I did this other cool project. That is something people really appreciate, and that gives you a lot of experience, a lot of practical experience, and people also, and hiring managers also appreciate having done projects and having done experiences and stuff like that you can talk about and you can share your excitement and these things. So yeah, as a summary, like engineering, just like and working on problems directly. And if you're interested in applying for those two things, I recommend checking out the job boards for those. If you're interested in like some of the positions, feel free to send me an email. You can drop me an email there, or like send me a LinkedIn message. I'm happy to assist you with that as well. Yeah.
Like talking about the excitement, okay, it's almost midnight, okay, like it's it's actually 27th of the March here today, so like we have actually passed the day, and there are people actually still here, listening to our conversation, so that like we are really excited with this. Coming up to this, like my friend Rishu actually had a question. Rishu?
Am I audible?
Yeah, you go.
Yeah. Hi, John. First of all, thank you for the interesting session. My question is, if you heard about GPT jailbreak, so my question is that GPT jailbreak is a way of like bypassing the filters. So in the context of that AI, is the filters really effective, or it is just a myth?
I think there are more effective ways to do filters than people are doing right now. I think the filters are pretty terrible. And the filters are flawed for a very, very basic reason, which is that they try to have a monolithic AI system, and where the system needs to know intuitively what is correct and what is not correct. And therefore, inevitably, if you try to make that robust, what you will have to do is like make the system less capable. And so there's this clear trade-off between the robustness of the system and its capabilities, because it needs to cover itself against all possible things you could ever say, and some of which might actually be valid questions and so on. And so I think there's like in this unavoidable tension between these two things. I think actually the approach that's Vertebra is following is slightly different, is more about building smaller systems that can be composed in clever ways, through like compositional setups, or like things like factored cognition and things like that, where this is each module in the system has a very limited task that is very targeted, and therefore it is much easier to determine what are things that should be doing or shouldn't be doing, and also how it should be aligned and so on. And so I think that is like already the architectural problem is like a really big deal. I think making a system that has like a 50 quintillion parameters, not that anyone has built this at all, but like imagine the limit of like something ridiculous. There's like a really massive system. Doing RLHF on this to prevent it from jailbreak is basically impossible. And so I think that is just going to be something that is going to like not work in the limit. I think other architectures are going to have to emerge, or other alignment mechanisms people are going to have to come up with. At the same time, I also think that I think the jailbreak should be something that people can opt into, actually. I think the filters aren't really, the current filters aren't really the problem. Like, preventing people from saying good things about Donald Trump is really a total misnomer of the problem. I think actually people should be allowed to say those things if they want to read them or whatever. I think that is almost in the edge of censorship and things like these. And it just sort of is like it's sort of trying to confuse the problem to sort of pretend like we are actually doing safety work. As a counter argument for the things I said before, that OpenAI is really worried about safety. I think to some degree it is true to say that they're actually worried about safety theater and pretending that they are doing safety work. Much of it is aligned with real safety work. Some of it is not so much. And so like the political dynamics here are like an unavoidable. But I think that is why it's really good there's open source AI where you can just take the model and fine tune it to do whatever you want. You don't need to worry about these like stupid filters. And so I think really what the filters are supposed to be for is like when the user that is using the system actually wants the filters to be in place. So if you are like designing a chatbot for the workplace, you probably do want the filters to be there because you want the topic to be a certain type. If you're designing a chatbot for debates and for like casual conversation with friends, you don't want some ridiculous filters about political topics because that's not what you're talking about. But maybe you do want to prevent the system from like sending emails about the conversation or something. So maybe you want to filter from the system sending emails or doing other things. And so I think the filters should really adapt to what the user is doing at each point in time and what the application is. I think trying to come up with a set of general filters that works for every circumstance and one size fits all sort of situation, I think is like not scalable. And I think we'll probably start seeing either dramatic stagnation of AI progress because of this limitation, or we will see that like systems will actually start being open sourced and like things like these. So I think, yeah, I'm more optimistic about the open source version of things. I think open source science is really good and really valuable, and so I'm excited about that. But we'll see what happens.
Yeah. So, follow-up question with the same subject. You had talked about example of picking a coin. So in that example, you were saying that I just commanded to pick the coin, but it learned that I have to go right each time, right? So my question is that my AI is learning extra. Whatever I saying to learn, he's learning something extra, right? So how I get to know that what extra he learned? As sometimes it's also dangerous that learning something extra is also dangerous, right?
Right. So I think the way they figured this out was like one way is like you just move the coin, and that's like a simple check. Another way is like you can actually check when the AI gets excited about stuff. So like you can see there's like a heat map of like what are areas where there's a saliency in rewards, expected rewards, and you can see when the system is misgeneralizing, the heat map is always hot on the end, on the right end, and so that the system always wants to walk to the right. But when the system is generalizing properly, the hot parts are only when the coins are showing up, and there's some interpretability there about what the system really wants. And so I think there are techniques that can be used to elicit these sort of sub goals or these things that people are learning. But I think it can also be hard to do things like these because humans also have instrumental goals, which sometimes often they forget. If you're like, if you ultimately what you care about is like having a happy life and whatever, maybe you'd like think, okay, I have to get a good job for that, I need to get a good degree for that, I need to like study for this exam, and then at some point your entire existence is just like maximizing the grade of some exam rather than like the long-term goal, which is which is like whatever that might be. Which is why I think a lot of the time the framing people should think about, well, this is sort of unrelated, but is more in terms of like not trying to compete with others. I think competition is like, competition can be very evil. Competition can be good for improving your skills, but it sort of reduces you to like a very narrow sort of game theory situation where the only thing you're trying to do is compete rather than maximizing what you really care about. I think AI systems suffer a little bit from this as well. Maybe we can learn from what humans do to like improve the way systems work in that sense. And so, yeah, I think this is like a lot of the problems that arise in AI are actually things humans manifest. Like reward hacking is something that happens all the time. Deception is something humans do all the time. Goal misgeneralization or whatever. It's like people do these things in practice. But there's also mechanisms why these things aren't a big deal for humans. And so maybe those are also insights we should look at, like not only what the problems are that humans have, but why these problems are contained and how can we like take these features that make the problems contained in human society and bring them into AI systems as well could be interesting. So there's that solution, but there's also the technical solution, which is like, can we build a heat map of what the AI wants or something like that, which obviously becomes more complex as the system scales in complexity. It's not so simple when it's no longer a video game or something like that.
Yeah. Like basically tracking each moment.
Yeah. Yeah.
Thank you.
Okay, so everyone, with this, we have actually come to the end of this session. Thank you, everyone, for joining in. Okay, it was a really great session, and it was really great to interact with you. I hope you had the same feeling with us.
Oh yeah, I had a really good fun. You guys asked extremely good questions, really interesting points, and had really good fun. I welcome everyone who wants to connect. Like send an email, send a message, whatever, and happy to answer any other questions or give any other advice. Or if you want to apply for any position, also happy to advise with that. And yeah, happy to come back anytime.
Thank you all. Thank you. Thank you for joining in. Thank you, everyone.
Thank you.
Thanks a
Bye-bye.
lot, Juan. Thank you.
Thank you, Ann.
Thanks, Mayank, for coordinating.
So everyone, I'm Mayank Jaiswal and I was the host for the today. And thank you for joining in the Razor session, okay? The Ramanujan Research Society, along with the Gear. And we keep doing these sessions, okay? So to interact and learn more things that, that we haven't learned yet. So thank you for joining in, everyone. Have a great day. Oh, come on, it's morning now. So good morning, everyone.